what's called an assimilation model. So you can see the hot Pacific. This is a La Nina going because the cool current is coming from the east. See it? Then we're getting a great big El Nino going, and that's going to be the warm water pushing across the globe. So there's La Nina, and let's see if I can find. Oh, here's El Nino.
What they did was.
So how is Asia doing in El Nino?
What?
How is South Asia doing in El Nino?
Well, in El Ninos, let's just take a look at South Asia. Where are you from?
I'm from India.
India.
Yeah,
Okay, you see that the Indian Ocean is tremendously hot during a El Nino.
Yeah.
So it's almost like an extension. The warm pool, that very dark stuff. And so you see, and let's just go through time and just see what happens. Look how much cooler it is here. So this is the La Nina, and then we bring up the El Nino. So there's the real, here's the real winter La Nina. You see how much cooler it is. Then you see you get an El Nino. You see how much hotter it is. I guess that's in the monsoon.
Yeah, I'm from the South India, and they were telling me it is 3 degrees or 4 degrees higher than usual at this time.
Oh, it's going to be really something. The new El Nino.
I'm noticing the raise in temperature year after year so far.
Oh, it's definitely going up.
Almost 25 years, you know. And people are not realizing that.
Where did you say you're located?
I'm in Hyderabad.
Heidelberg?
Yeah, Hyderabad.
Hyderabad.
Yeah,
you're in India then.
Yes.
Yeah, Hyderabad.
Sandy, can you spin that? So we're looking at North America. We want to talk about AMOC.
North America coming up.
Oh, stop. So Florida on. Okay, good. Look at that straight. Okay, so now this has. Now you have to think upwelling. We're going to talk about this. The circulation through the depths at the top, and you have to think about how the Gulf Stream works. So it goes up, and then it goes across over England and bounces up, and then it goes banging down Africa, Spain, and then it crosses over again. Right, Sandy? Am I right? Okay. So
That's what it does. It comes all the way around from the Pacific and up into the Caribbean. So there's another one that kind of shows that the currents a little
I
bit.
was on the right track.
So.
Are you able to explain AMOC and why it's such a big point and why it's important?
Everything. So I was head of NOAA's research.
Sandy, can you project your voice?
Yeah.
Get that microphone back, will you?
So
you were head of NOAA's research.
yeah, and so we talked a lot about that. And the thing about it is, there's another. I hesitate to go try find it because last time it took me like 10, 15 minutes to get back to this. But what you see here is when you look here. In fact, I think I can show it a little bit. So I'm going to bring this one up and bring it around. So the AMOC actually starts as the warm water from the Pacific comes all the way across and hits Africa, and you see the little eddies as this current comes. You see them?
Eddy point.
Yeah. So the eddies coming down there, and then they come around the Horn of Africa, and they make it all the way over here. You can still see the flow here coming this way. It flows into the Caribbean and then up around Florida, the Florida current. And as Chip was just pointing out, it takes off, for Iceland and Europe. You see that thing moving north. So that's the Atlantic meridional overturning circulation. And we call it overturning because we learned about 30 years ago with a famous guy by the name of Walter Monk that he thought, and now Jim Hansen says it's really true, that it is going to basically stop because of global warming. But I'll show you what it looks like.
And why is it so important?
It's so important because it's basically what made Europe warm. You
England
come
can grow
over here
food.
to Canada,
It allows England to grow food.
England to grow food, and Canada to be, it's 30 degrees colder at the same latitude in Canada.
Exactly.
Because this warm water is going up there. So Chip's going to show
England
us.
up here should be like that over there.
Right. Okay, so so what I want to show you is what the AMOC does to climate. Okay, you ready? We'll go to climate. So this is a NOAA Earth System model. I'm going to stop it. Stop. So this is, see, it says 2024 Earth System Model 4. So that's one of the models. I think actually this is a National Science Foundation one. I always claim, because I have to, that the NOAA ones are better. But the big thing about the Earth System models, they have everything. They have the carbon cycle. They have the thawing of the high latitude snow. They have the interaction of all the plants and so on. And so when we bring it around in 2024 and we look at the Atlantic, we see this really cold area. And the big thing about this is not so much what I'm going to show you about how that area where this current comes all the way around the Earth up by Iceland, and then it sinks into the deep ocean and brings up cold water. So I'm going to go ahead and run this thing.
And while he's on that, it also
Through
brings up
time.
the krill, I think, right? The food
Yeah, I can
stuff.
show you the krill by Antarctica in a bit, Chip, if you want to look at it.
So it brings the food stock for ocean life?
It
Big
does.
time.
Actually, I'll show you the ocean life. So we're going through time here now. This is
2099.
Yeah, it's getting
2100.
pretty
Yeah.
dire.
so.
Oh my god.
So this.
What the hell?
So there's the
Hell is the right word.
there's what's left. The ocean
It is
circulation
right here.
is sinking and bringing up cool water, but the planet itself, the land is in this case about 15 degrees warmer
Not
than
very
that
pleasant.
Oh my god.
at our current rate. So it's just basically the land gets warmer, and the biggest thing is there's 500 parts per million of CO2 in the permafrost, and that's as much as all the humans have taken out. And according to the top scientists that worked in my lab, he's the world's best expert. He says 500 parts per million of CO2 are going to come out. When we, it takes like 100 and 200 years. So in other words, we get to
As Siberia warms.
And there's no reversing that, or is there a way to halt that release?
well, it's us working.
That's what the
together
supergrid
because-
does.
Yeah,
Are you talking about the
supergrid-
methane craft rates, or are you talking about something else?
No, I'm
Methane?
talking about the permafrost, which is in the land. And the cloth rates are also a big problem because methane has got such a big blast.
Yeah.
And in the Paleocene, Eocene thermal maximum, it's clear that there was a big blast of methane and just launched an incredibly hot Earth.
So you're talking about that's on top of this, the
Yeah, on
methane
top of
craft
this,
rate.
yeah.
Okay, great, perfect.
So now you were asking kind of about the biology, right? Of life, what
Mhm.
the high latitude life.
Mhm.
So I have the high latitude life because if you were here for the talk, you'd have seen this all in order. But this is this is phytoplankton.
Okay.
So it's the chlorophyll, and you can kind of see the amount of chlorophyll is in the color coding. See it there on the
Yeah.
lower, and it's so blue is very little. And so if you come around to the Pacific and Atlantic that we know better, in fact, let's do the Atlantic.
What is the unit that's kind of
and it's chlorophyll.
1150, 1170.
I don't know. I'd have to go look. Something about micrograms per liter or something.
Yeah, that's what it looks like.
So what we see is that this area in the lower latitudes is the ocean desert, and the high latitudes, because there's upwelling and it brings up the nutrients, is where this tremendously dense phytoplankton growth is, and that's why the cod fisheries are off of New England. And look at Europe; they're basically not only getting warm water, they were also being fed by this fabulous.
Apparently, all the whale poop is very positive.
And so the argument that our NOAA fisheries people are making is that as the ocean gets hotter, it stops this, and the whole ocean becomes more like what we see at 30 degrees and 40 degrees north, and very little life. So we get deserts encroaching in the low latitude land, and we get much less ocean life because both the phytoplankton are not getting the nutrients, and a very real big thing that one of the scientists that worked at our Seattle lab proved is that by the time we get to late in the century, the little shellfish, it's so acidic, it's 80% more acidic, the shells dissolve. You can't grow the ocean life.
Because of the acidity.
Wait, are the shellfish having trouble yet?
And warmer water doesn't retain oxygen in its solution, so free oxygen that the fish breathe in their gills.
But I think the shellfish are still making their shells okay so far.
Well, they're making their shells, but the higher latitude you go, it's starting to get tough at high latitudes.
They're seeing the shellfish are having trouble.
It's just beginning, but it's
Yeah.
definitely happening.
I guess it also depends on ocean's acidity, right? So,
Yeah, I mean-
this is basically calcium
So
carbonate.
you guys remember the event that happened?
productivities at high latitudes and my little interactive.
Do you guys remember the event that happened 2 years ago or 4 years ago up in the Olympic Peninsula, where it was like 110 for a week, and all the shellfish died?
No.
Yeah, this happened. Maybe it was 5 years ago. I can't remember which summer that was, but it was it gave a great stink to the entire Olympic. It
So
was
this
really.
this is from the NOAA satellite, and you can see the snow go south in the winter and come back north in the summer. And you can also see how the rhythm of life in the Atlantic is that in the springtime you get this tremendous bloom of phytoplankton, and then over the year it decreases in the middle of winter, and then it starts back up in the summer.
See how big Greenland is?
Yeah.
Sir, isn't the temperature rise also would increase the algal blooms, toxic algal blooms in the water, because oxygen would escape and
You're going to
carbon
get
dioxide-
more toxic algal blooms,
Yeah.
but those are particularly in bays and near shores.
Yes.
That's where you see more of
So how do
that.
we factor all the fresh water that's melting off of Greenland into the ocean, messing with all that fresh water?
Maybe the carbon tracker.
Okay, we have the carbon tracker. It's not as nice as some of them that we've done, but I have the carbon tracker.